Welcome! Today we'll solve a problem involving the mean value theorem for the function f of x equals the square root of x squared minus 4. Let's first visualize this function on the interval from 2 to 4. Here's our coordinate system. And here's our function, which is the top half of a hyperbola. The mean value theorem states that if a function is continuous on a closed interval and differentiable on its interior, then there exists at least one point C, where the derivative equals the average rate of change over the interval. Let's mark our endpoints at x equals 2 and x equals 4. First, let's verify the conditions. The derivative of our function is x over the square root of x squared minus 4. The function is continuous on 2, 4, and differentiable on 2, 4, so the mean value theorem applies. According to the theorem, we first find the average rate of change by connecting the endpoints with a secant line. This gives us f of 4 minus f of 2 over 4 minus 2. Now, we set this equal to the derivative evaluated at some point c. This gives us the equation c over square root of c squared minus 4 equals square root of 12 over 2. Let's solve this equation step by step. First, squaring both sides and simplifying, we get c squared over c squared minus 4 equals 3. Cross multiply to get 3c squared minus 12 equals c squared. Simplify to get 2c squared equals 12, or c squared equals 6. Therefore, c equals plus or minus square root of 6. Since we need c to be between 2 and 4, we can only use the positive value. Here's the point where c equals square root of 6, and its tangent line has the same slope as our secant line. And thus, we verified the mean value theorem for this function and found the exact point where it occurs. C equals square root of 6.